Good morning. I'm just setting up here for our class. This will be Pre-Cal 30. So let me just open the notes here. Just having some trouble with starting up stuff. So now that I got it going, I'll get everything started up here for you. So today is September 6th. We're looking at Pre-Cal 30. If you're watching this, obviously you're online now. I'm going to do three things today in our class. Okay, the first thing is make sure you've watched the introductory video on the top there before we start the first unit. The first unit here that we're looking into is the unit circle and all the angles and all that kind of stuff. So some of it's going to be reviewed today from Pre-Cal 20, and some of it might be just new if depending on how good our summer memories are. So let me just open up what I started here from the other day here. So let's pop that open. Okay, so today's September 6th here, and my name is Mr. E or Mr. Englot. I'll be teaching you this year in Pre-Cal 30. Oops, got a little glitch there. And the three things that we're going to look at today in September 6th or day one. We'll call it day one because you might be a few days behind depending on when you started the course. So day one, and also known as September 6th for us here in Vanguard. And we're going to review the radian measure and be able to convert it to degrees. Okay, that's something you did in Pre-Cal 20. We're going to look at angle and coterminal legs and angles in standard position as well as reference angles. So all that stuff about angles in the quadrants, and look at arc length in the circles. These should all be relatively familiar to you from your Pre-Cal 20 days. Okay, I'm going to just hide this out of my way. I'm going to try to keep this video around half an hour. So let's start out with reviewing the radian measure first. Okay, so let's pop the page up here. Okay, so the first thing we're going to look at is radian measure. So let me just adjust my typing here to the appropriate size. Okay, so we're going to look at radians. Oops, I have two I's in there. Okay, now when you're talking about radians in terms of mathematics, by the way, we're following the Pre-Cal 12 book. If you don't have one of these, let me know and I'll get it to you. Okay, and we're starting off in section 4.1. Okay, so that's where we're at. We're not starting the first chapter. We're going to do chapter 4, 5 first, as it says in our outline there. Okay, so when you're talking about radians, talking about a measurement of angles as compared to the measure of the central angle in a circle to the arc length on the edge. Okay, so radian is that angle measure that compares the arc length and radius of a circle period. So given the central angle, of course. Forming, I guess, not given, forming a central angle. Okay, so look something like this. If you remember, let's just pop the tools up here, and I'll draw a little circle here, if I can remember where they are down here. Oh, they're up here. All right, so insert shape. Tool, there we are. Shape. And we'll just pop a little circle in here. Okay, so if we've got this circle and we've got our center in here, okay, so I'm just going to have to guess. I forgot what. So we got our center in here, and we have some radius here, R, and we have our radius there. This angle here, theta, which is tended by some arc length right here. So this would be our arc length. Okay, usually the symbol that we used in the past would be an S. Okay, so that's what a radian measure is. And the relationship between radian measure is that the angle in radian measure theta is equal to, okay, the division, if you're looking at it, it's the distance around the circle compared to the radius. So that's S divided by R. Okay, so if the radius is 1, then however how long and the arc length was 1, then you'd have a radian of 1. Okay, 1 divided by 1 is equal 1. Okay, now we know from, this is the relationship of it. This is our arc length, this is our radius. I guess we should put that in there. Make sure we're not assuming people remember things. Okay, and this is our central angle. And that central angle has to be in radians for this to work. Okay? Has to be in radians for that to work. If it's in degrees, it doesn't work. Okay, so that's how a radian is defined. It's the length of the arc compared to the radius, and that gives us a radian measure for that angle that it subtends, or that the arc length touches on both edges of that. So that's basically what a radian is. We'll look at that formula a little bit deeper later. So the relationship that we know is that the distance around, if we assume that we have a 1 radius, the distance around a circle is the circumference. Now, the circumference is 2 pi r. Okay, so 2 pi r, if the radius is 1, that's what we call the unit circle, which we'll look at in depth next section. The unit, if we assume we have a radius of 1, then the distance around the circle will be 2 pi r. So 1 for radius, and then the distance, 2 pi for s. So that means 2 pi radians would be the distance for going around a full circle. So that tells us that we know that there's 360 degrees in a circle. And we know that we have 2 pi radians in a circle. And I'm just going to sort it by saying rads. Okay, now the rad, there's no symbol for rads. Like degrees has a little symbol like this by, if you see just a number without any symbol like that, then we assume that's in rads. So this tells us the relationship between a degree and rad is that 360 degrees is equal to 2 pi radians. So if we basically reduce the 2 out of there, we can say therefore, that's what these 3 dots mean, 180 degrees is equal to pi radians. Okay, and that's the relationship we have. So that brings us to our first objective of the day, and that's how to convert from radians to degrees or degrees to radians. So we can use a relationship, okay, of, now sometimes, especially in Pre-Calc 30, we'll want you to leave the pi there because pi is an exact, it's an exact expression. Well, it's not an exact expression if we take it down to decimals, but if we don't take it down to decimals and write it as pi, it gives us what they call an exact value, an exact value of pi. Okay, just like root 2 is an exact value rather than 1.41 something. Okay, so when they ask you to use exact values, stick with pi's and whole numbers and try not to put in decimals. If they say estimated values, you can stick in decimals. Most of the time we use exact values. So that is what we're going to do first. Our first objective then is to look at an example of converting. Okay, so this is where the 1 came in. Excuse me for a second. I'm just going to change make sure I get that. There we go. That's better. So we're going to come in with an example, and maybe I'll type this just to make it a little neater to start here. Okay, so let's get. Okay, this is the first example of this section. Converting radians and degrees. Either way. So we can use the relationship. So our example, let's go, let's say we have 5 over 8 pi. I got to use the marker for this, sorry, because I don't have a pi type button in here. So let's just put in it. So let's say I have 5 over 8 pi radians into degrees. Okay, so the easiest way to do this is ratioing. So if we say, if we do a ratio of radians on top and degrees on the bottom, we go pi radians over 180 degrees. That's the relationship that we know from the circle. And that ones that we want to convert to, we put our radians on top, 5/8 pi radians over X number of degrees, or some value. So we'll say n degrees. Okay, so pi n, if we do this, cross multiplication, is equal to 5/8 pi times 180 degrees. Okay, so to get n, oops, what am I doing here? Sorry about that. Let's just undo that part there. Where's my undo button on here? Where did you go? It's got to be right here. There we go. Control Z, I always forget. Okay, so we're going to divide by, sorry about that, guys. Pi and pi on both sides to get rid of this pi on each side. So these pi's will cancel out nicely. Forgot the 180 there. Sorry. Degrees, because we're doing this, right? Okay, so 5/8, the pi's canceled. 5 times 180 divided by 8. So take out our calculator. 5 times 180 divided by 8. And I had 112.5 degrees. Now we can leave that as a decimal there, because that's our answer. Okay, that's converting from degrees and radians. Okay, very, very straightforward stuff. Okay, stuff we probably did in Pre-Cal 20. Okay, obviously we can do the other way, so let's do a quick one of that. Call that A and B. Okay, so convert, let's say 405 degrees to radians. Use exact value. That means don't delete the pi out of it. Okay, so let's go, same idea, pi over 180 equals, okay, now we got to change where we want the n, because we want radians this time, so the n goes on top, or x or whatever, and we want our 405 down here. So we cross multiply this way, we get 405 degrees times pi equals 180 degrees n. So we got to divide both sides by 180 degrees. Okay, now if we don't want that decimal, if we want to leave the pi, we have to reduce this into a fraction number. So 405 divided by 180, okay? And then divided by a common number to get your fraction, okay? So in my case, my calculator works in fractions. So it's not, oops, I'll put it up there for you. So when you divide 405 by 180, you get 9 over 4. So basically, I've divided both sides. If you know, if you're dividing some number 180 by 40, or was it 90 would be 2, so 45. You divide everything by 45, you get 90 over 9 over 4. So that's 9 over 4 pi radians, okay? Or 2 1/4 radians, if you like mixed fractions. So this is 9 over 4 pi equals n, which is, this is our radians here. Okay, that's an example of converting both ways. Okay, so we're still, like I said, I want to keep this in the half an hour range. So, okay, that's our first objective for today. So that's converting back and forth. So if we look back on our beginning objective, we've got this done. Okay, we've got the angle measure and the converting. So now we want to look at, okay, the arc length. Well, actually, we did this one too. Look at the arc length of a circle formula as well. Didn't do an example with it, but we'll save that to the end. Now we'll look at the quadrant and coterminal angles and reference angles. Okay, that's a review as well. So let's flip ahead here. Okay. So if you need me, if I'm going a little too fast, pause the video if you want or whatever you need to do. I'll just hang out here a little bit in case I was going fast. Okay. And while you're doing that, I'm just going to talk about how you can get in contact with me. Okay. Don't forget to watch that introductory video. Contact me if you need to. You can use the Screencastify little program here to help yourself out. If you have a little question, ask me and then send it off to me, or you can just email me a question and I'll get back to you. Okay, so let's look at objective number 2 here. And that's standard angles, position, I guess, and reference angles, and coterminal. Oops, they are there. Okay, so that's what we're going to look at. And what we'll do first of all is we'll just draw the quadrant here first. So if I just draw in our X and Y, okay, and okay, one revolution is 2 pi radians or 360 degrees. So if we're looking around this circle, if this is the middle of it and this is X and Y, let me go back to a marker here. Should always label those. Okay, in this position here, we have 0 degrees, 0 rads. Okay, as we go up, this is 90 degrees. And 90 degrees is pi over 2 rads. Okay, I'm just going to keep the rad second. Okay, this is 180. We know that 180 degrees is a pi. That's how I know half of it was pi over 2. And over here, we know this is 270 degrees or 3 pi over 2. Or 1.5 pi. And then over here we have, also when we come back to it, it could be 360 degrees or 2 pi radians. That's a pi. Let me fix that up a little bit. Okay, this is pi, 2 pi here. Okay, 2 pi. Okay, so if you have any angle, let's use a different color here and an arrow to represent it rather than a, I want it that thick. Well, let's make it thinner. And we'll just use a little arrow, okay? Okay, so if I'm in here, and I have this angle, okay, an angle in standard position, we always measure the angle from the positive x-axis for standard position angles. This is an angle in standard position. Okay. Now we can have a coterminal angle if we go around one. So if this is theta, we don't know what it is. We're just imagining it's something like 100. Okay, theta degrees. Okay, we can also have a coterminal angle, which I'll do in a different color red. If I go around and then come back to that same position, okay, So I'm adding an extra 2 pi radians or an extra 360 degrees. We call the red part an angle which is coterminal. Okay, and we'll do the and then these are all positive angles, so positive angles go this way. So positive angles, positive measures are in that direction. And then we can also have negative angles, which we'll do in blue here, which would go, instead of going in the counterclockwise position, we'll go down first. They go like this, in that direction. Okay, so we can also have this angle. So they can be read in a different way. Okay, so this would be a negative coterminal angle. Okay, and okay, so then we can also look at one more thing. I'm running out of colors. Okay, if we look at in the quadrant, in any quadrant that you have, if you remember, the quadrants go 1, 2, 3, and 4. And if we want to have a reference angle is in any quadrant is always measured from the x-axis. So this would be an example of a reference angle. Okay, so a reference angle, okay, it's always measured from the x-axis in a particular quadrant. Okay, so we're going to do a couple examples using these standard positions, negative angles, and so forth. And that'll be our objective for today. And I'll do an example of a circle radian thing as well, and then we'll give you some practice. Okay, so let's do some examples here on this page. We'll go down a little bit. Okay, and let's say that we have this type of question. Let's say, pop into typing here again. So let's say, before I do that, I should go back up here. Before I give you an example, for any coterminal angle, which we'll go back to red here because I totally forgot about this. Okay, for any coterminal angle, you're just adding another 360 degrees every time. So a coterminal angle formula, which we'll do in red here. So let's make sure I got my red on. We'll use the marker again. Okay, so any coterminal angle formula, if you have some angle theta, it's theta plus 360 degrees times a number, n. Okay, where n equals 1, 2, etc., 3, 4, 5, whatever it might be. Okay, and you can also replace the 360 with 2 pi if you're doing radians. Okay, so it's not really a really important thing, but just something to remember from pre-calc 20. Okay, so let's go back and do this example that I want to look at for this. Okay, so let's set that back up by going to typing here. Okay, so let's just do one simple example. Given the angle, do a negative one, let's say negative 80 degrees. Find the standard position angle reference angle and a coterminal angle. Okay, so let's do that by just drawing it out. You don't necessarily have to if you can think it out, but let's do that. Okay, so I'll draw my little axis over here. I won't make it as big as the last one. Oops, that's still the purple line. Let's go to the black line here instead. Okay, there we are. Okay, so negative 80 degrees. So that means it's going to be down here somewhere. So let me get that arrow now. Okay, so starting here. So we know that this angle right here is negative 80 degrees. Okay, this is our initial X and Y. Okay, so we can say, well, we know that the reference angle is equal to 80 degrees. Okay, because with the X-axis in the fourth quadrant, it's still 80 degrees. Okay, if we come around here for the standard position angle, okay, we know that this is 270 plus another 10, or this is 360 minus 80, depending on how you want to do it. So theta standard, I'm going to go 360 degrees minus the 80 degrees. Okay, so that's going to be equal to 200, oops, flipping my thing around, 280 degrees. Okay, now if we were doing pi or radians, you'd have to be careful with your fractions, subtracting and stuff like that, but we'll just do an example in degrees right now. And then the last thing I asked you, a coterminal angle. So we can say, well, a coterminal angle could be 280 degrees plus any multiple of 360. So let's go 360 times 2, just for fun. 280 degrees plus another 360, or and in my case, I wanted to go 2 for whatever reason I wanted. So that's another 720. So a coterminal angle then would be a nice even 1,000 degrees there, I guess it is. Okay, 720 plus 280. Or you could do a negative one as well. Okay, so that's an example of that. So the last thing we have is last example, and then I'll give you some practice today, and hopefully I'll keep this under a reasonable amount of time. Our last objective, if we flip the page here, is to look at using the radian angle formula. Okay, key thing here is to remember it must be in radians. Angle must be in radians. Okay, so let's do one that's not in rad, so we have to convert to. So let's do an example. What is the arc length in a circle with a radius of, let's say, 3 meters, 3.0 meters, let's go a little, and a central angle of, with a degree, so we have to convert it, 100 degrees. Question mark. So the first step that we're going to do here is we're going to be looking at taking this and converting it to our radians first. So that's our first step. So we know from our formula before, we know that 180 degrees is equal to a pi radian. Okay, so that tells us that's our basic rule or formula that we need. Now you can put that on a formula sheet somewhere. As I said in my introductory video that I did for you guys, don't forget that you can build up a cheat sheet, formula sheet for the year And you can have a 11 by 8.5 page that you can bring in at the final exam. Can't do it during unit exams. I'll give you formula sheets for that, but you can bring it in for the final exam. So you can, and help you doing when you're working on stuff. So we got pi over 180 is equal to something over 100, n over 100, because we want to get it in radians. Okay, so if we do that cross multiplication, 100 pi equals 180 n. Now this is where you're going to probably have to use an approximation of pi because we're actually trying to get a number, but for now we'll just leave it. We'll divide by 180 on both sides. So we got 100 pi over 180, okay, equals n. So this is going to be n, or central angle, is equal to, if we divide that by 10 over 18, or we divide that by another 2, 5 over 9 pi rads. Okay, now we can apply the formula. So remember the formula is that pi equals the arc length divided by the radius. Now if I want the arc length, that means I can multiply both sides by r. Okay, multiply by r here, multiply by r here, the r's cancel. So this is, SOR is another way to remember the arc length formula. Arc length equals the degree, or sorry, not degrees, the angle in radians times the the radius. So in our case, S is equal to 5 over 9 pi radians times 3. Now, you might not want to leave this in the pi form depending on how the book looks at it, but if you wanted to, you could. This would just be 15 over pi, because we could divide out the, cancel out the 3 here, cancel out the 9 into a 3, divide by, because that's how you do fractions. Hopefully you're solid with fractions. So this would be 5 over 3 pi meters. Okay, now if you don't like it in pi, you just multiply by 3.14. So you can go, or use your pi button, you go 5 divided by 3, okay? And then just multiply by pi if you have a pi button, or 3.14. So you can also say that that is 5.24 meters. Okay, and this one, you could use decimals. It's reasonable to use decimals because you won't want an exact, who has pi on their meter stick? Not too many people. Okay, so that's our 3 examples that we had. So just reviewing quickly before we run out of time here. I think we're around that 30-minute range anyway. Okay, and I'm going to give you some practice. Just reviewing quickly. Okay, the radian measure is theta equals the arc length over the radius. Okay, we know that 360 degrees is equal to 2 pi, or 180 degrees equals pi radians. You can convert using a ratio, okay, and doing cross multiplication, canceling. Okay, and then we did a couple examples of that, going the other way, going to radians and degrees, something we did in pre-cal 20. Okay, next thing is standard position reference and coterminal angles. Okay, and the quadrants 1, 2, 3, and 4, and the terminal areas of 0 degrees, 90 degrees, 180, and 270 also can be 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay, and those things, and looking at an example like that. Okay, and finally, what we did was an arc length one. Okay, we did an arc length. So what I want you to do for some practice, let's get the textbook out here, and then we'll stop the video. Okay, the practices will always be at the end of the videos. If that doesn't work for you guys, let me know, and I'll post them up too in the Moodle page as well. Sometimes I'll break the videos into 2 parts depending on the day, and I'll always have the length of them so you know how much time you need to get through them. Okay, so you can be looking. This is section 4.1 on page 175, 176. Okay, and we're looking at basically, you can do 2 1 column. I don't care which one. Let's say B, D, F. Okay. Then, of course, you can, it says express your answers in exact values and approximate measures to the near. Okay, so approximate measures mean no pi, exact values mean pi. So you can do number 3, B, D, and F again, second column. Okay, that's converting back and forth. Same thing with 4 and 5. B, D, and F. Okay, you don't have to do everything all the time, but do some practice. Okay, sketching here. Let's see which one has a good sketching. Okay, 6. I guess we'll just do 6, B, D, and F again. And then the last one you can do is you can do 13, A and C, I guess. That's okay, and that should be good for understanding this first concept. So if you do those 3 for today, hopefully you'll be fine. I'm going to stop the video here. If you have any questions, get a hold of me, robertenglot.com or at gmail.com. Okay, that's my email if you have any. Looks like this. No. Okay, no capital letters in anything there. All right, good luck. I'm really looking forward to working with you guys this year. Don't be afraid to ask me questions. I'm not sure who everybody is, but make sure you're sending me an email that you want to use to get back and forth. Shade, I had you last year. Braden, I also had you last year. So I know you 2 guys already. Cody, I didn't have you. So I did get an email from you already. Thank you. And I think we had a person added to us. I think Taylor from Gull Lake was added with us yesterday. So Taylor as well. Just watch the introductory video as well. You guys might be a day or 2 behind me, which would be okay if you get a little bit behind, because I won't be putting these up like I did today. I'm trying to keep ahead of you guys. I won't get that far ahead of you because I'm going to do them with my class in Vanguard. Right now I'm doing them beforehand, and then I'll do some with my class in Vanguard. So if you do, if it's September, I'm going to do day 1, day 2, day 3, day 4 of the unit, and I also put the day that we did it in Vanguard. So you may do day 1 and on September 6th in Vanguard, but it might be day 1, September 7th for you, which is okay as long as you're within a couple of days. It's okay. All right. So good luck. Let me get that. I always forget where there it is. Stop sign. So good luck.